Okay, so natural logarithms. This has popped up so much in mathematics that we've decided to give it its own logarithm, okay? So the natural logarithm, we want to know what e is. So there's another video that you should have watched before this that gives a very brief explanation of what e is, and you can dive into YouTube and there's all sorts of crazy mathematicians that will explain where e came from and stuff, but e is a lot like pi. It's an irrational number that just pops up everywhere. Okay, just like pi pops up everywhere, e is another one of these mathematical numbers that's irrational that will pop up everywhere. Okay, its approximate value is 2.71828. Now you don't have to remember that, but yeah. So base e, exponential functions with base e are called natural base exponential functions. Okay, so that would be like f of x equals e to the x. Now base e logarithmic functions are called natural logarithms, and that would be log base e of x, and it's often abbreviated ln of x. Okay, so I think the ln, like natural logarithm, it should be nl, but ln of x. And if you look at your calculator, if you have it in front of you, there's a log button right next to the 7. The ln button is right next to the 4. Even our calculator has a button for this. Okay? So let's just go through some, basically we've done all of this, but we've just not done it with natural logarithms. So now let's go do this all with natural logarithms. So let's switch forms here. That's going to be log base e of 24 equals x, which is the same thing as ln of 24 equals x. That one's ln of x equals 9. ln of 72 equals x plus 5. If we're going to switch back to exponential form, you can rewrite this as log base e of x equals 58. So that would be e to the 58th power equals x. This one would be e to the x equals 6. This would be e to the 32nd equals x minus 9. Okay. Now condensing these, same properties apply. Addition goes with multiplication. Subtraction goes with division. If there's a number in front, it's a power. Okay. I want you to do this part and check your answers. So there's the answers to those ones. Okay. If you got them wrong, come talk to me in class. I will show you how to get them. Okay. Now let's get into solving these. So same rules apply. If we have a log equals a log, well, those can just cancel. You have 4x minus 27 equals 15 minus 2x. But you get 6x equals 42, so x equals 7. Check it. Get 1 for both of those. Both 1 is positive, so we're good. This one, so let's condense it first. So condense the left, condense the right. So that's going to be ln of 72 over 4 equals ln of 6 times a minus 2. So that's going to be ln of 18 equals ln of 6a minus 12. Cancel those ln's. You get 18 equals 6a minus 12. 30 equals 6a, so a equals 5. Plug that in to the only place with a variable. You get a positive number. Okay, this one, we have to change forms here. So that's the same thing as log base e of 8x equals 2. So that's going to be e squared equals 8x. There is a button for e in your calculator. It is the division sign. So if you put second and then the division sign, that will give you e in the calculator. I'll write it right here. So second division sign, whoops, equals e in the calculator. Okay, so then put that in your calculator and you get, oh look, I did it right there. 7.3891 is approximately, that's why I used that, because we rounded this off, so it's approximately 8x. Divide by that 8, and you get x is approximately 0.9236. You can plug it in, and it's a positive number, so we're good. This one, so this time we need to change forms back to the logarithm. So that's going to be log base e of 57 equals x, which is ln of 57 equals x. There's a button in the calculator. ln of 57 is approximately 4.0431. So that's approximately what x equals. Okay? This one, so I'm going to get rid of that 5 first, divide it. So I have e to the 4n equals 19. Change form, so that's ln of 19 equals 4n. Well, ln of 19 is 2.9444, approximately equal to 4n. Divide by 4, and you get n is approximately 0.7361. Okay. Remember to take the quiz. Have a good day. Bye.